Hello and welcome to this webinar entitled Beyond OEE, Achieve World-Class Productivity. My name is Fraser Thompson. I am the MES consultant here with Cimlogic, and I'll be taking you through this presentation and demonstration today. A couple of things before we get into it. We're going to be covering off obviously beyond OEE, but first of all we're going to take a look at what OEE is and why it may not be enough to meet our manufacturing productivity needs today, and what other factors might affect performance of production equipment, manufacturing cells and so on. What other tools can be used, such as SPC, HACCP. And if you do have any questions, there'll be a section in the GoToWebinar panel on your right hand side that will enable you to add your questions there. We will be answering some of those questions towards the end of the webinar, so please fill those in as we go along, and we'll do our best if we have time to answer them all. If we don't have time to answer all those questions, we will follow up with an email response to all your questions in the coming week. Okay, let's step into the webinar. So, just as a brief introduction first to Cimlogic, we are a systems integrator based over in Saltaire, West Yorkshire, a lovely part of the country. We've been working in the UK manufacturing industry now since 1997, and we are partnered with Parsec Automation, who are based over in California, who are the developers of the TrakSYS MOM or MES platform. We integrate and deliver solutions using TrakSYS to manufacturing companies in the UK and Ireland and further afield also. We pride ourselves on high quality on-time delivery that really enables our customers to be world-class performers through improved productivity, improved energy efficiency, and so on. TrakSYS itself is deployed in over 80 countries worldwide. As I said, Parsec are headquartered over in California in the States, and they have a partner network of around 46 partners currently worldwide. So we have coverage from South America, Europe, the Far East and Africa, pretty much worldwide coverage. And within that sort of install base in 80 countries, there's a large customer base as well in multiple verticals. So food and beverage manufacturing, consumer packaged goods, petrochemical, automotive. So we pretty much have the tools to meet your needs regardless of your particular manufacturing vertical. So what is the need for world-class productivity? Well, as we all know, the manufacturing environment is becoming more and more globalized. Competition from overseas is looking to drive everybody's efficiency and productivity measures. And knowledge of OEE is very common now. Lots of people are adopting OEE as a metric to be used, and use of OEE within the industry is definitely expanding. Everybody has the same needs to do more with less, regardless of what your industry is, and everybody's looking for standards and tools to use in order to become market leaders. So, world-class productivity is no longer a nice to have, or measuring OEE is no longer a nice to have. It is absolutely essential to manufacturing in the current day and age. What is best-in-class OEE? Well, world-class manufacturing OEE used to be said to be around 85%, but from a recent study there by the Aberdeen Group, best-in-class has come out around 91% OEE. But that very much depends on the portfolio of work and works orders that you are completing in your individual manufacturing environment. If you're in an environment where you're doing high-volume, long production runs, then higher levels of OEE would very much be expected. If you're doing short volumes, high numbers of changeovers, then your targets may need to be much lower given the volume of changeovers that you're doing. So it's important for, although we say best-in-class targets are 91, it's important for targets that we set ourselves are both achievable and also challenging. We don't want to be in a position where we're chasing a rainbow of an OEE score that, in reality, given what we manufacture, we're never going to be able to meet. We all want to reduce our scrap, our waste materials, and identify these opportunities to be able to improve. and also looking there at any regulatory compliance, any audit trails, and data logging that may be required is all drivers really for world-class productivity. So again, as I mentioned before we get into going beyond OEE, let's have a look at OEE in a little bit more detail and ask ourselves the question, is it enough? Basically, OEE is a very reliable metric for understanding and improving machine performance. But not all OEE tools can make information available in real time. And this is important because real-time information is actionable in real time. We can make real-time differences to our efficiency, to our performance, and to our OEE score if information is available to the right people at the right time. But OEE may be too equipment-centric. It may be looking at only factors related to the equipment that affect productivity, whereas what we tend to find is that equipment will perform reasonably well. Some issues that tend to revolve around the equipment and the equipment performance tend to be in the way it's configured, the way it's set up, in the procedures and the process and the operations that are performed on those machines that cause it to run inefficiently. So increasing our OEE scores to world-class level typically requires additional tools that are going to drive this continuous improvement all the way through the value chain, through goods in to goods out. So OEE, the answer is it's not a silver bullet, it's just one tool in our toolbox, and with TrakSYS we're offering you a complete toolbox of which OEE is just a single part of it. The number of OEE solutions available in the market is vast and is growing day by day. There are more OEE solutions out there. It can be as simple as writing yourself a very simple Excel spreadsheet and manual data collection to get yourself recording OEE and reporting on it. But some of the advantages that we bring with TrakSYS again enable us to do this in real time, present actionable knowledge, and give this to the people who are then able to carry out those actions. So going beyond OEE is the main focus again this webinar, and we're going to focus on some of the other tools within TrakSYS that enable us to take that next step to becoming a completely integrated solution that not only allows us to monitor but also extend and improve our production, our performance and our profitability. We're going to realise those gains with a rising percentage of OEE and OEE score. And some of the options we have on there that we're going to talk through really are task and quality management, workflow tracking execution, online statistical process control, dynamic email, SMS notifications, tracking labour management and the skills of the labour force, and also financial KPIs. Again, everybody understands pounds and pence. If you don't understand the calculation behind OEE, then presenting a loss to somebody in financial terms is often very much more obvious. So let's take a look at going beyond OEE, now this time specifically with TrakSYS in mind. So as it says there, TrakSYS is a software application and solution platform designed to manage manufacturing operations in real time. And there are a number of areas where we can focus on here. Again, we've touched on some of these previously, but quality and SPC, maintenance management, looking at historians for data trending, materials and inventory, correct plant scheduling are all tools that are part of the TrakSYS toolbox that enable us to drive up OEE and go that one step further once we've begun to record and manage our OEE. We're able to bring data from multiple sources and contextualize this to drive improvement in real time, and by this we mean data from shop floor equipment, from PLCs, from machinery, from equipment in real time, but also to add context to that via operators. A machine may be able to tell us that a service door was opened at a specific time and how long that door was open for and how long the machine was in a state of downtime. The operator can contextualise that and tell us why they opened that particular door at that point in time. So this is very much based on intelligence-based decision making rather than opinions and gut feelings. With the information that we get from TrakSYS, it's reliable. We can spend more of our time then actioning the knowledge rather than debating its actual information in there. It's going to enable us to give us real tangible gains. So I'm going to step into the live TrakSYS demonstration there. As I mentioned earlier, if you do have any questions, please enter those into the GoToMeeting control panel down on the right hand side. And if we do have some time towards the end of this webinar, we will endeavour to answer as many of those as we possibly can. What I'm going to do now is just step across to my demonstration. As we can see here, I've flicked across to my internet browser. So I'll just give you a little bit of background on TrakSYS beforehand. TrakSYS is based on Microsoft.NET technology. It's a reports and operator interfaces are available via web browsers, so there is no client software to install to enable you to view or interact with the system. And it can be from a single server on site to multiple servers, completely depending on your network architecture, your IT requirements, and the size and volume of data that we're going to be connecting. In this particular example, I'm running a full TrakSYS installation from my laptop with a database, albeit a reasonably small database. So we can take multiple inputs again from our equipment, from our operators, and present those to you in a number of different forms. So let's step into the demonstration a little bit, and we'll start on this particular dashboard. So if just make that full screen. What we can see here is a traditional sort of OEE overview dashboard. This is the presentation of the information that's stored in the TrakSYS database. I've got some of my tabular information down the left hand side here. I can see what my current OEE score is for the date and time range that we've selected. And I can see how that OEE is broken down into its substituent parts: availability, performance, and quality. We can look at things like cycle time, takt times, and as well as looking at it in tabular form, we can see that in graphical form here also. So I've got my OEE score of 49.6%. If I hover over, I bring up a little pop-up, and where possible and where data is available, using TrakSYS, we can build in pop-ups and other reports from click-throughs. In this case, by clicking on the OEE bar, I can look at my OEE trend shift by shift over the same date time range and see if we're on a positive trend, a downward trend, if we're staying very active or very, very steady on our OEE. We can also identify the high performing shifts. See, we can get up to sort of 63%. We've demonstrated that. Why is it that, for example, this shift was able to run at 63% and this shift able to run at only 42%? And again, through drilling down and looking through all the information, we should be able to get to those answers. We can also see here that we've got information based on time, based on unit counts. We can split our time down into production time, not scheduled time, availability lost time. And of that good production time, again, we can see what was good, what was bad quality. What did we lose through poor quality? So here again, the click down brings me into some data that displays the exact number of cases or units that were lost and what the reasons for those losses were. Was it mechanical related quality issues themselves, or issues related to the raw materials? If we go through to my time chart here and I click through into my availability loss section, we can again see that brings me into a quick Pareto of my top 5 or my top 10 downtime reasons for the same date time range. And this gives us the information straight away to be able to focus on what our top downtime is. In this case, it's been assigned to changeovers. And the click-throughs go as far as the data. So in this case, I can see all of my individual changeovers that occurred during this date time range, what products we were on, what shift was on at this particular time. And we can also see the individual data for the event itself, what labels, from what supplier we were using, what bottle supplier we were using, all of the sort of raw inputs, the raw information that we've captured. We could look at that in a slightly different format. So here I've got another OEE type view. Again, this time my pie chart is a complete breakdown of time. I've got my runtime, manual events, so reasons that the line was not running that were not due to machines but down to the operators, the configuration, whether it be lunch breaks, meetings, other. And we can then break our downtime down into multiple areas. So here I've chosen to break them down into starvation, not scheduled time, faults, and blocked. And again, I've got indications of my top 5 losses for this particular line. If we flip across now to the real-time tab, What this is going to show us is a quick representation of what the operator might see on the shop floor. So typically we will provide a PC interface on the shop floor, again running purely a web browser. It's connected to your network so it can see the data on the server. And this will present some very key information to the operators. Firstly, we're able to tell them, or they're able to tell us, exactly what product they're running, what job they're running. So all of the information we record is related to that job, that product family. We know what shift they're on. We can present to the operators their live OEE and again availability, performance and quality in real time. So this is key. As they progress through the shift, the needles will move up and down, go into the green and red, and they can see the impact of their actions on their OEE score in real time. And again, through connections to the machinery, we'll be able to pick up when the line or when certain equipment goes into a downtime state. In this case, I've simulated a label jam. It's currently an active downtime, as is indicated by the red bar here in my event list. I can see the time that it started, and I'm actively logging the duration as long as it's going for. So your operators or your engineers would do what they do. They'd get the line back up and running again. And in this case, it may take a number of seconds, a number of minutes. I've recorded it as 25 seconds. The line has gone back to a green, a running state. And that could be the end of that. But that's purely just the equipment related information. So the line PLCs or line controllers have told us that we're experiencing a label jam, and we experienced it for 25 seconds. But again, the operator can add some additional context to that. So what we would typically do is we would predefine a list of root causes that the operator was able to select from. In this case, we detected a label jam, but the actual root cause for that label jam was a misaligned label roll that was down to a training error. So this particular operator did not have the appropriate training to set up that labeler, and it caused us 25 seconds of downtime. And we can see when we save that away, that gets stored in here as a label jam with a training error. So when we do our Pareto analysis, again we can do our analysis on both machine codes but also root causes from operators. So that's given us this actionable knowledge in real time, but what we can also do and present to the operators here is a little bit of a view into the future. By giving them a real-time indication of their current shift progress and using the data from the shift, such as their current OEE, we can begin to make targets and projections about where they're going to be at the end of the shift or at what time they're going to finish a particular job run. In this particular example, I'm looking at some shift-centric data. So we're saying that in order to complete this job or to complete this shift, I should make 14,000 units. I've currently made 8,500 units, hence the progress bar here. And if I continued from now until the end of the shift at my current rate of OEE at 53.4%, I would hit my my projected unit count, which would be 11,500. Now, as an operator, if I was to improve my OEE score from 53% to 100% and run from now until the end of the shift, the best case units I could produce would be 15,500, as indicated by the yellow arrow. And the reality is, obviously, we'd like to be better than we are currently projecting by improving our OEE score, but getting to 100% may be slightly unachievable given this particular order or this particular line. So we're giving them this information to make those projections, again, in real time. Planners and schedulers can use that information to predict when they're going to need raw materials for the next production run, or when we're going to need the changeover staff to come in and do the sanitisation or the clean down. So we've covered now a little bit about sort of capturing information from the equipment to generate our OEE statistics, our OEE metrics. Now we're going to go the next step. We're going to go beyond OEE and look at other factors that are not equipment centric that could affect us. And we're going to start by focusing on task management. So over here in this particular list, I can see that I've got a number of tasks that have been completed previously. I can trigger some automatic tasks that need to be completed. For this particular line here, I've triggered a HACCP check. Again, this could be either a time-based trigger or an event-based trigger to complete this HACCP check. Here I've got this check that says it's due at 3:21 PM, and as the operator, again, I can click into that. They would be required to enter their user ID potentially. That could be via just straight keyboard entry. It could be via scanning a barcode. It could be via scanning an RFID or a swipe card. Here we can see that in this particular example I'm required to enter a tank filler temperature, so I might enter 45 degrees in this case, and then they've got a number of checks to complete. So I'm going to test my metal detector. That was a pass. I'm going to clear the scrap from the caser. I've done that. I'm going to check I've got soap available. Yes, I've definitely got soap available. I'm going to inspect for damaged products. Have I done that inspection? Yes, I have. Again, that gets recorded off and saved away in here, so I can see all passes along the line there. Now, if I go ahead and create another HACCP check task, what we can do is we can simulate some failures. And what we're going to do by doing this is introduce an element of workflow management. So, for example, if I don't enter a filling tank temperature and try and save away that check, or if I don't fill in a number of the examples, I've built in some logic behind the scenes then, or some validation on the data that's been entered by the operators. So the operator didn't enter their user ID, that's required. The filler tank temperature cannot be 0, it must be between 20 and 50 degrees. Must select a response from each of the 4 checks. And again, these can all be configured very simply via a simple web form. So in this case I'm going to go ahead and fill in the red items as I was supposed to. I've got a 50-degree tank temperature in this case, but in this case I've got a failed metal detector. I've definitely cleared the scrap away. I haven't got any soap available in this particular case, and yes, I've inspected for damaged products. So I'm going to save that particular HACCP check away. We can see that's been recorded. I've got a failure in my test for metal detection, a failure in my soap available checks, and that has automatically triggered 2 additional checks or 2 additional workflows for the operators to complete. So first of all, we've configured the system to request the operator to recalibrate the metal detector. So again, the user signs in, it's metal detector 1, I've performed the recalibration and I've inspected the filler, and now the test is a pass. And we can save that away. Again, that's going to get recorded for our analysis later on. Here again, a slightly different form. I've got a soap refill to complete, my operator name, and now I've actually completed this soap refill and save it away. So although I had 2 failed actions, I've now completed the actions that were required of me in order to pass that particular test. So now we've had a look at task management. Something else that leads on quite smoothly actually with task management would be statistical process control. So if I click across to my next tab here, what we're going to look at is the SPC module within Traxxas. So Traxxas has a number of standard SPC charts, X-bar, Q-sums, that are available for general use, and we can trigger tasks in the same way as we did on the HACCP sheet here. So in this case I'm going to do a fill weight task. That's going to trigger a task for me to take a number of samples from the line and check their fill weight. Here again, that's appeared on either a time or an event-based trigger. And as I fill my data in, again that should populate into the SPC chart below. I'm looking here behind the scenes that I've got a upper and lower limits set that should be between 90 and 94. So I'm going to go ahead and enter my information into the system. So sample 1 was 94, sample 2 was 95, a 96, a 95, and a 96. So I've entered some quite heavy sample data in there, and save that particular set of readings. And what we see that now does is plots a new point on my SPC chart with an average of 95.2, and that again can be used to generate certain triggers or alarms. Because it's gone red, it's over my UCL limit. We can use that to trigger another workflow that might be to send an email to say, quality department, you need to come and check this, the fill weight is too high, we need to make an adjustment, or so on. What we can also do as another example of that is to do inspections. So my bottom SPC chart here is looking at bottle inspections. So I'm going to trigger another task. In this particular case, that's going to cause me to do some SPC bottle inspections. And again, another standard web form that we can open up and again complete. So in this case, I'd taken 10 samples. I had 1 with cap damage, I had 2 with label damage, and 2 with bottle damage. And again, those results will be plotted equally on my my SPC chart there. So that's a little bit of an idea to how we can use SPC again within Traxxas to manage the quality element of our OEE. So we've looked at some task management, those non-equipment related issues that may affect our OEE score. We've also looked at the deeper lying quality issues. What we're able to do also there is look at excuse me, is how that quality varies. So now I've recorded all of this SPC data, we look and see what our quality percentage is by shift, and again here over a wider time range, looking at those individual shifts. If we had a particularly poor performing quality shift, we look at our losses by count or by cost. Again, they may not be equal. In this case, quality losses on the filler may not be as expensive as a quality loss on the labeler, because we've added some more value to the product in the process. So it's important to make that distinction between those two. And I've got a number of other tasks in here just as an example of the kind of forms that we can build in to Traxxas. In this case, I've got an hourly fill weight check. Rather than me just entering the information into the system, here we can capture information live from some scales that we may have, and again have an instant check that our results are within our mean. We can also link that to some electronic documentation. So if I don't know how to complete a fill weight check, again I can present the operator with their SOP. This is how you perform a fill weight check: take a number of samples, put them on the scale, enter the data in. And again, in this case I've got a username and password to sign off. And again, that's saved away in the system there for all to see at a later date. So what we're going to look at now is what else we can do. And if we remember back to our original Pareto chart, one of our top loss reasons was actually changeovers. And changeovers are important. Although we're not producing during a changeover, the length that a changeover takes, the length of time a changeover takes, can affect the amount of time that is available for us to perform changeovers. So on my operator interface again, I have a little button over on the left hand side that I've configured to initiate a changeover. And I'm going to go ahead and start a particular changeover in here. And what we've done behind the scenes in Traxxas is we've configured a changeover as a sequence of operations that need to occur, and the steps within that sequence have all been defined. In this case I've got a line clearance, a sanitization, a material change, a setup and a startup, and each of those steps has been defined and given a target time. In this case my line clearance has been given a target time of 0.5 minutes. And now as it's gone red, we can see that I've gone over my 0.5 minute target time, so I'm no longer in an on-target changeover. I'm in an over-target changeover. So in order for us to go to the next step, to this sanitization step, again we can bring in some other workflows. So in this case, I've brought up an error to the operator. They haven't closed the valve that I needed to. In this case I've just had a quick button that's going to trigger the valve to be closed. It's now gone green, and I'm going to say the reason for this particular step taking longer than required was document related. I didn't have the documentation to confirm that the line clearance was okay. I'm going to save that off and continue with my changeover. And now my next step has begun. I'm now eating into my sanitization step. And on we would go through the changeover process. I'm not going to complete the full changeover here. I'm just going to skip ahead and end that particular changeover. We can see it appeared to the operator as an event with a time. So if we now go into some more reporting on these particular changeovers, it might be that we want to study a particular element of a changeover that's causing us some problems. This particular tab is going to take us to an improvement dashboard that we've built. And again, using the journal feature that's available within Traxxas, we can start to do some SMED analysis. In this particular example, I can see all of my changeovers, their actual time versus the target time. And if we go to the report above, we can see a particular step versus its target time for those same changeovers. And we can see in this case that this step takes longer than the target time continuously. So we've put together a team. We're going to do some SMED work on this particular step of our changeover and record various notes and options. At this particular point, we've defined an action. We're going to try something new. We've saved it off as a time point. Yeah, that's indicated by the green bar here. And then very quickly, because all of the data is real time, every time we do a changeover, we can start to build up our before and after picture to see if that action has had a positive effect on that particular changeover. The next step on our journey, if you like, beyond OEE, is to look at maintenance. Again, preventative maintenance, predictive maintenance is very much key to making sure that our equipment is always available to be used and has the least amount of maintenance-related downtimes. And we can use TrakSYS either to generate work orders and maintenance tickets, or to integrate with, for example, an existing CMMS system that you may have to enhance the information that's available for it. In this particular dashboard, I've got I can see here again I've got a number of SOPs that are going to guide the maintenance or the engineering staff on how to perform an extruder clear activity, or how to change a roller chain, for example. And we can see that with TrakSYS and with data in TrakSYS, we can build maintenance schedules based on actual runtime, or actual units produced, rather than pure calendar time. In my particular example here, I've just got some buttons to trigger machine usage, so we can see that we start to build up a number of hours run between maintenance. That would go from normal into warning, and it may be that warning point is a trigger at which to perform a maintenance activity. Or it may be that we go straight ahead to our over hours, and that automatically, in this case, TrakSYS has seen that over hours and automatically triggered a PM activity for that extruder. So we can click on there, and again, the maintenance staff will be required to save off or confirm they completed a certain activity. It may be that they want to do a clean out activity. Again, here we can trigger those. We can trigger those activities manually or automatically. In this case, I'm manually triggering a clean out. And we can look at our maintenance by, in this case, it's a die, so I can see that maintenance is due on a particular item of equipment or not due. We could look at doing individual die changes. Again, I've replaced this particular part. I was the technician. Save. He's gone back now into a good state. And we can also request maintenance or maintenance responses and look at how maintenance are responding to downtimes. What's our mean time to repair, our average time to respond to maintenance requests. In this case, I'm going to put a request in. Here we go. I've got a maintenance request waiting for maintenance currently. As soon as our maintenance staff turn up, they might say, right, this request is now active. I'm actively looking at this. They'll do what they need to do to finish that particular request and finish it off there. So again, I've built up this time period for that particular maintenance request here to say I requested it, then the engineer arrived at this time and completed it by that time, and we can build that into our repair time, into our response time for our engineering. So one last point to look into is labour, and how labour may affect our OEE score, and how we may be able to fool our OEE score by throwing more labour at a problem. I've seen numerous cases whereby a line or a piece of equipment would have a very low OEE score, but that has been artificially manipulated by adding more labour or adding staff to the line to move product by hand around a machine that's currently experiencing downtime. Again, so it's important that we measure both labour and machine efficiency. In this particular case, I'm going to look at a batch-based process, so very similar to what we saw in the changeover. I've got an operator interface here with a job list. I'm going to pick the first job in the queue and start this particular batch, and within TrakSYS we've built in a number of steps to the process. Here we can see that those steps are all defined, and each step has a target time associated with it. Again, this setup time has here a target and an actual, but I can see here that I've got invalid labour resources for this particular activity, for this particular batch. Again, we can configure within TrakSYS knowledge about labour requirements or skills requirements for each individual works order. Here I'm required to have one supervisor, two operator ones, one operator two, one QC and one maintenance, and none of which have currently logged into the system. So I'm going to go ahead and sign in a few people. They can either scan their badge or enter manually. Again, I'm going to enter two operators into the system. And go down the list until we've completed the requirements that are needed in order to process this particular batch. And finally, one maintenance technician. We can now see that I've got all my labour requirements, and my labour status has gone to OK. I'm now permitted to continue to execute this batch. Actually, my setup has now taken longer than expected. So again, we're going to ask the guys why this was. In this case, it was down to a personnel shortage. And that's going to go ahead and proceed the batch. So that's covered off a little bit of the labour management. So that concludes the demonstration part of this particular webinar. I'll just take us back over to our slide and open up the floor to some of the questions that were entered on the GoToWebinar panel. So I just have a look down here. I can see the first question in here is how does the task validation get configured? Does it need programming? Okay, so let's have a look behind the scenes in TrakSYS to start with here. If we go across into what is called Model Track, this is where we build the model and the configuration of your plant, your system. And here we can see that I've got all of my production areas defined. I've got a batching, a tableting, a packaging area. And further down in this areas and systems view, I can see that I've got again some task form item groups here that have been configured. So in my check here, I've got a filling HACCP metal detector check that's been configured. So each of those actions that need to be performed during a HACCP check have been defined here. So I need to perform a detector ID, or I need to select the detector ID. Again, that can be either 1, 2 or 3, that's all been configured in there. I need to perform a recalibration. And again, that's a discrete, it's a yes or a no, it's a have you done it or haven't you. We need to inspect the filler and also perform the test result, the pass-fail again. I've got the same again for my my soap fill, has it been completed successfully. So all of my definitions are completed within here. If I go, for example, into my liquid fill area 1, each of those HACCP checks again that appear down the bottom here are available as a form I can open into and see if, for example, a task fails. I've triggered an alert track in this case to send an email to the filling supervisors group, and again that can be seen from the alert track window. I can again see all the email notifications that have been required to be triggered. In this particular case, I've got a filling SBC rule violation trigger. I've got a task due or a task failed trigger to send an email, and again we can configure it to suit. So the system is built around being able to use drag and drop down lists to configure. You shouldn't need to write any code to configure task form items. Okay, I think I've just about got time for another question. I'll take the next one on the list. Can TrakSYS interface to SAP, for example, to create works orders? Okay, so the simple answer to that is yes, we can interface to SAP or many other business systems, ERP systems such as Microsoft Dynamics, Infor, and also other shop floor systems, other PLC DCS systems via OPC. The amount of interfaces is almost limitless, really. TrakSYS has a number of inbuilt APIs that allow us to communicate with SAP using remote function calls, for example, RFCs. We can also do XML data exchange. And these kind of interfaces would be, again, managed through or configured through the Model Track engine through a service that we call IntelliTrack. So here again, I've got an ERP data exchange that's scheduled to run every 5 minutes through IntelliTrack service. Again, this time we are configuring it again on a sort of code basis. This would be more using the TrakSYS API and would require some additional coding. But again, the data in the TrakSYS database is not closed off. It's available to be queried by other systems if needs be. So, unfortunately, that's all the time we've got there to pick up those questions. Some of the other questions that we've got, we will answer shortly with an email. Again, if you would like to contact us further, you can visit our website at www.cimlogic.co.uk. This webinar and others will be able to be viewed on demand. You can call us in the UK there on 01274 599 955, or please feel free to email me. That's fraser.thompson@cimlogic.co.uk if you have any other questions or would like me to go through any other detail further. Once again, thank you all for your time and thank you for watching.